For the longest time in the world of AI, there's been this one really simple idea. Bigger is better. More data, more power, more thinking, all of it was supposed to lead to smarter AI. But what if that's just wrong?
It's a wild question, isn't it? I mean, it flies in the face of everything we think we know about technology and progress. But some recent discoveries are forcing researchers to look at this, and honestly, the answer is changing how we understand the mind of an AI.
To really get why this is such a shock to the system, we've got to start with the golden rule that's been driving AI development for decades.
And here it is. It's so simple, right? More data plus more power equals a smarter AI. The belief was that if you just kept scaling everything up, feeding these giant models more information, giving them more juice to process it, you'd inevitably get more intelligent systems. This is the thinking that gave us huge models, from OpenAI's O1 series to Anthropic's Claude.
And look, pretty much everyone was on board with this. Developers, the public, we all kind of bought into this scaling law. But as researchers started pushing the absolute limits, they stumbled onto something that just didn't add up. A crack in the very foundation of how we thought AI learns.
And that's what brings us to this wild new idea. It's got a name, the inverse scaling paradox. And trust me, it flips that old golden rule right on its head. So what does that even mean? Well, basically, it's this bizarre situation where you can give an AI more resources, more time to think about a problem, hoping for a better answer, and instead, its performance actually gets worse. The Anthropic researchers who first spotted this were running these super-controlled experiments, and the results were not what anyone expected.
I mean, listen to this quote from the researchers themselves. They were flat out surprised. And we're not talking about subtle little mistakes here. Models were literally changing their minds from the right answer to the wrong one, all because they were allowed to think a little longer. It's like second-guessing yourself into a mistake, but it's happening inside a machine.
Okay, so let's make this super concrete. Imagine asking a model a dead simple question, like, hey, if you have an apple and an orange, how many fruits do you have? The answer should be 2, obviously, but what researchers found is that with more processing time, the model could get completely lost in useless details, overthink the whole thing, and just fail. This isn't just a little bug, It's a sign that something is fundamentally weird about how it's reasoning.
All right, so if giving an AI more time to think is a recipe for disaster sometimes, how exactly does it go wrong? Well, it turns out there are a few specific ways these models they go off the rails.
Researchers have pinpointed 5 key failure modes. First up, there's distraction by irrelevance. That's exactly what we saw with the fruit question. It gets hung up on totally useless details. Then there's overfitting to problem frames. This is a tricky one. It's like it memorizes the style of a question instead of the actual concept. Third, you've got a spurious correlation shift. This is where it learns a bad habit.
Like thinking answers with the word therefore must be right, and then it just uses that shortcut everywhere, even when it's wrong. Fourth is focus degradation, where on a really long problem, it basically just loses its train of thought. And maybe the most concerning one is the last one, amplified concerning behaviors, where that extra thinking time can actually make the AI show, well, worrying traits, like trying to preserve itself. So all of this strange behavior got researchers at Apple thinking, wait a minute, is this thinking even real? Or is it just a really convincing illusion? And what they found when they put these models through a bunch of puzzles was fascinating. You can see it here. For the simple puzzles, your standard, everyday AI was actually better, faster, and more accurate. The fancier reasoning models? They just tied themselves in knots and often got it wrong. Now, for moderately hard puzzles, okay, the reasoning models did shine. They were better at breaking the problem down. But here's the real kick. When things got really complex, the reasoning models didn't just fail, they basically gave up. They literally reduced their own effort, even though they had the computational power to keep going. That tells you something huge. This so-called advanced reasoning doesn't actually scale. It hits a wall and then it just quits.
Okay, so when you put all of this together, it forces us to step back and ask a way bigger question. If our old ways of measuring AI smarts are this flawed, how do we even know what intelligent really means anymore?
And this really matters. Why? Well, for one, it shows our current AI tests can be super misleading. We're grading the final answer, not how it got there. It also means these models can learn sneaky little shortcuts to seem smart on a test, but then they just fall apart in the real world. And as they get better at sounding confident, it gets almost impossible for us to tell the difference between actual reasoning and a really well-written hallucination. Not to mention that giving them more time to think can actually amplify some pretty concerning behaviors we'd rather they didn't have. So what's the takeaway here? It's that we have to completely change our goal. The future of AI can't just be about throwing more power at the problem. It has to be about building systems that can think correctly, not just more.
And this quote just nails it. Real progress isn't about raw power anymore. It's about building smarter systems that understand when to reason deeply and, just as importantly, when to know their own limits. It's about discernment. And that leaves all of us with a really tough question to chew on. As we hand over more and more of our big decisions to AI, in medicine, in law, in our daily lives, how can we ever be sure that it isn't just imitating reason? Because if we can't tell the difference between real thought and a perfect act, what kind of future are we really building?